Imagine a bustling workshop. There's sawdust in the air, tools clinking, and a project taking shape. Now, picture a workbench right in the center. This is where the magic happens. It's where the artisan keeps their most important tool, the one they use constantly. In the world of computers, that workbench is the CPU, and that essential tool is the accumulator. The accumulator is a special register inside the CPU. It's like a scratch pad where the computer stores numbers while it's working. Just like an artisan needs a place to hold their tools, the CPU needs a place to hold data while it's performing operations. The accumulator is essential for even the simplest calculations. It's the heart of the computer, beating with every addition, subtraction, and comparison. Without it, computers would be lost in a sea of numbers, unable to perform even the most basic tasks. In the early days of computing, accumulators were even more important. They were the primary way that computers stored and manipulated data. As computers have evolved, so too has the role of the accumulator. But its importance remains, a testament to its elegant simplicity and enduring power. To understand accumulators, we need to peek inside the CPU, the brain of a computer. Imagine a microscopic city, buzzing with activity. Data whizzes through circuits like cars on a highway, each with a destination. At the heart of this city lies the accumulator, a central processing hub. The CPU performs calculations, makes decisions, and controls everything the computer does. It uses the accumulator for almost every operation. Picture it like this. When you add two numbers on a calculator, the result appears on the display. In a CPU, that display is the accumulator. When the CPU needs to add two numbers, it fetches the first number from memory and places it in the accumulator. Then it grabs the second number and adds it to the value already in the accumulator. The result? It's stored right back in the accumulator, ready for the next operation. This constant back and forth between the accumulator and the CPU makes calculations efficient. It minimizes the need to access memory, speeding up the entire process. The accumulator is like a master juggler, keeping all the data in the air, flowing smoothly from one operation to the next. Now imagine building a complex machine piece by piece. Each component requires multiple steps, and each step builds upon the last. In the world of computers, complex calculations are like building that machine. This is where the accumulator truly shines. Let's say we want to calculate the average of three numbers. The CPU first adds the first two numbers, storing the result in the accumulator. Then it adds the third number to the accumulator, updating the sum. Finally, it divides the sum by 3, storing the average back in the accumulator. Without an accumulator, each intermediate result would require a trip to memory and back. This constant shuffling of data would slow down the calculation, making the computer less efficient. Think of it like baking a cake. You wouldn't put the batter in the oven after every ingredient, would you? You'd mix everything in a bowl first. The accumulator is like that bowl, holding all the ingredients or data in one place, making the process faster and more efficient. Accumulator machines, a blast from the programming past. In the early days of computing, when computers were as big as rooms and as slow as molasses in January, a particular type of computer architecture reigned supreme, the accumulator machine. These machines were built around the accumulator, reflecting its central role in computation. Programming an accumulator machine was like writing a recipe. Each instruction was a step, and the accumulator was the mixing bowl. For instance, an instruction might say, load the value at memory location X into the accumulator, followed by add the value at memory location Y to the accumulator. These early computers may seem primitive now, but they laid the groundwork for modern computing. The accumulator, with its simplicity and efficiency, was at the heart of it all. Programming these machines required a deep understanding of the accumulator, as programmers had to carefully manage its contents at every step. While accumulator machines are mostly a relic of the past, their influence can still be felt today. Understanding how they worked gives us a greater appreciation for the elegance and efficiency of the accumulator, a concept that continues to shape modern computing. From simple addition to modern CPUs, the evolution of the accumulator, like a species evolving over millennia, the accumulator has adapted to the changing landscape of computer architecture. While it remains a fundamental component of modern CPUs, its role has become more nuanced and sophisticated. Modern CPUs often have multiple accumulators, sometimes called general-purpose registers. This allows them to perform operations in parallel, juggling multiple pieces of data simultaneously. Imagine a chef with several mixing bowls, each dedicated to a different part of the recipe. That's what multiple accumulators allow a CPU to do. Furthermore, modern CPUs can perform more complex operations directly on data stored in memory, reducing the need to constantly move data to and from the accumulator. This is like having a blender built into your countertop. You can process ingredients directly without having to transfer them to a separate bowl. Despite these advancements, the fundamental principle of the accumulator remains the same, to provide a dedicated location for holding intermediate values during calculations. It's a testament to the elegance and efficiency of this concept that it has endured through decades of technological advancements. Accumulators in the modern age, still relevant, still powerful. You might be thinking, if CPUs are so advanced now, do they even need accumulators anymore? The answer is a resounding yes. While their role has evolved, accumulators are still crucial for the speed and efficiency of modern computers. Think of the apps on your smartphone, the video games you play, or the websites you browse. All of these rely on billions of calculations per second, and the accumulator is still a key player behind the scenes. Even though modern CPUs are incredibly complex, they still rely on the basic principles of the accumulator. By minimizing data movement and providing a dedicated workspace for the CPU, accumulators enable the lightning-fast performance we've come to expect from our devices. The next time you open an app, stream a movie, or play a game, remember the humble accumulator working tirelessly behind the scenes. It's a testament to the enduring power of simple, elegant solutions in the ever-evolving world of technology. The legacy of the accumulator, a foundation for modern computing. The accumulator, though often hidden from view, stands as a testament to the ingenuity of early computer pioneers. It represents a fundamental concept in computing, the need for a dedicated space to hold and manipulate data. This simple idea paved the way for the complex, high-performance computers we rely on today. As we venture further into the digital age with artificial intelligence, quantum computing, and other groundbreaking technologies on the horizon, the legacy of the accumulator lives on. It serves as a reminder that even the most complex systems are built upon a foundation of elegant, fundamental principles. So, the next time you marvel at the power of a computer, take a moment to appreciate the humble accumulator. It may be small, but its impact on the world of technology is immeasurable. The accumulator is a silent hero, quietly crunching numbers and enabling the digital wonders of our modern world. You've been watching ScanderLoud. Please subscribe.